Okay, I want to do a video here, one of the bearing problems, but where you also actually have to find a bearing. So I'm going to use a problem that was in 7.9. It was number 3. Okay, so remember when you draw these problems, you want to be as accurate as possible and make sure you're labeling angles as you go. So you've got an airplane leaves the airport and flies on a bearing of 200 degrees for 200 miles. Okay, so let's start here. So we've got our starting point, and it goes on a bearing of 200, so 180 plus 20, and it's going for 200 miles. So I'll label that as 200, and maybe I'll do my angles in red. So the bearing we said was 200 degrees, so after 180, this little angle here is 20 degrees. Okay, and then it changes course. So let's go back to changing course here and to going on a bearing of 340 degrees for 500 miles. So again, from due north here, I'm going to go 340, and I'm going more than double the distance now. So that was 500. And all right, well, we can actually label some more angles here. We said that bearing was 340, so this is 20 that is left over. But we also know the other side here is also 20 because alternate interior angles are congruent. So I've got this angle here, in other words, is 40 degrees. And the first question here is how far and on what bearing, that'll be the second question, does the airplane need to fly on the return trip? So we're trying to find this distance here. I'll call that X. So that's going to be the easier part. I've got SAS, so I can use the law of cosines to find that distance. The second piece here will be to find the bearing, which means, so from this final, I'll call this my starting point, and this is my where I ended here. So from this end point, it's asking what is the bearing to get to the line of travel, to that blue line. And so I really need to find at this angle here. So again, what is the bearing to get to that line of travel? Well, to do that, I think the best way is to think that angle is going to be 180 minus, and I've got to subtract this angle here and this angle here. I actually know what this angle is. Alternate interior angles are congruent, so it's 20, and I get that from this angle. So I've got 20 degrees here. However, I don't know this angle. I'm going to call it just y degrees. And so my bearing is going to be 180 minus subtracting out that 20 degree angle and subtracting out whatever that y is. So I can use, once I find x using the law of cosines, I can use law of sines to find that y angle. And that'll be our bearing, 180 minus 20 plus that y angle. All right, so let's do the first part, which is finding this distance. So the law of cosines, x squared is going to be 500 squared plus 200 squared minus 2 times 500 times 200 times cosine of that included angle, which is 40. And solving for x squared and then taking the square root, I get x is 369.85 miles. Okay, so that was the answer to the first part. And now in order to find the bearing, I now need to know that y value. So I'm going to use the law of sines. Sine of y over 200 equals sine of 40 over that x that I just found, 369.85. And I'm going to get y to be 20.34 degrees. So thus going back to our bearing, this is going to be 180 minus 20 plus 20.34 degrees. So the bearing here will be 139.7 degrees, or about that. Okay. Finding a